Welcome everyone to our Tech Excellence meetup. So for today, I have some really great news. As you know, our community has been really rapidly growing, and we have already nearly 2,000 members on Meetup. I'm really excited to announce that Daniel Moka will also be joining us as a co-host for our Tech Excellence meetups. So Daniel is a software craftsman at Mocha IT, and he's also the founder of the TDD manifesto. So I'm really looking forward to this.
Hey everyone, thank you very much for introducing me. It's a pleasure to be part of this small meetup. And let me start with the introduction of the session of today. We are Tech Excellence. Our vision is to raise the bar of technical excellence across the world. Here are our speakers we had in the past. I highly recommend everyone to check their speaks out. You can find them in YouTube. We had really great and amazing talks. And from here on, we can see the speakers of the future. We have a really great and exciting sessions planned already. So please stay tuned with us. Of course, you can follow us and you can find us in a lot of places, for example, in Meetup, YouTube. You can also find us on LinkedIn, Twitter, and last but not least on GitHub. And a huge thanks to Optivem, who is our biggest sponsor, and it wouldn't be this whole session meetup would not be possible without them. Okay, I would like to introduce to all of you our speaker of today. His name is Peter Schuler from the Netherlands. He is a senior Java developer at Rabobank in the Netherlands. And the title of his talk will be Bigger Unit Tests Are Better. Why small unit test classes will slow you down. Personally, I'm super excited for these sessions. I'm looking forward to this. One thing before we start, please, if you have any questions during the sessions, feel free to ask. You can ask it in YouTube comment sections, and at the end, we will dedicate time for your question, and Peter or all of us will answer to those. So Peter, I'm going to hand over the microphone to you. I wish you good luck, and the stage is yours.
Thank you, Daniel. Well, welcome everybody to my talk. Bigger unit tests are better. And let's see what this really means. There will be some code, there will be some interaction with you all, so don't shy away. First, a little bit about me. Actually, all the interesting stuff has already been said. I'm a Java developer. I'm a big enthusiast for clean code and test-driven development, code quality. Also, I like do a little bit of gardening. I live in the Netherlands. I'm married. I have 3 daughters and 3 dogs in that particular order. Um, and also, interesting fact about me is that I am actually quite tall. I am quite big. I'm 2 meters and 4 centimeters. I'll try to show you that how much of me there is so high. Um, which also means that things being bigger has a natural appeal to me. Bigger is better. And that's a very normal thing to think in life. I mean, think about it. If you want to have a bigger house, a bigger paycheck, you want to have a bigger car. So bigger is really better. But when you think about that, when we do coding, I actually like things to be small. I like my classes to be small. I like my functions to be small, preferably just a single line of code. So um, then why do I like my unit tests to be bigger? Well, I will talk about that. I will explain first of you, what do I mean with bigger? Why do we write unit tests? That's a sidetrack I'm really curious to hear your opinion about. I will explain why they should be bigger. We will look at how we can make them bigger and how big is big enough. So what do I mean with making unit tests bigger? I really strongly feel that when you write unit tests and at the current paradigm that we use, that a unit test should test a single class should change, and we should focus more on this. A unit test should test a bigger scope. So when I mean that I want to make unit tests bigger, I actually mean that I want to give them a bigger test scope. And that is basically what this talk is about. But before we go any further, I have a question for you. I want you to tell me why you do unit testing. So if all's well, there will be a link in the chat. You can also scan the QR code, or you can be very, very fast and type everything you want in the address bar. But I would like ask you to join the word cloud. I will now try to find the right screen. That is also something that is then with multiple screens also a little bit of a hassle. But I would invite you all to share with me why you think we should unit test. And I did this already a few times. I'm really curious what the answer will be. So don't be shy, people. Take out your phone, scan the QR code, just put in your name. It's just um, a small thing to share with me why you think um, that we should unit test. And I imagine that everybody is now scrambling for his phone or trying to find it. I see something very cool. There's more fun for coding. I think that is indeed a very important side effect of doing test-driven development and writing unit tests, that they're really fun to do. And you will show you that if you make them bigger, there will even be more fun in them. A peace of mind. That's also a very good one. I once had somebody said, I want to be able to sleep at night. There's some very small letters, and I'm getting a little bit older, so I need to be closer. To drive design, get fast feedback, catch bugs early. Okay. All these answers tell me already that this is a really, really senior crowd that has a lot of experience, at least the people who are putting in their thoughts. Confidence, I see there, that is also very important then. One, fast isolated tests. Well, that's an interesting topic that we will touch today. How isolated should your tests be? To catch regression and lose fear of refactoring. Yeah, so all these things are actually something that that we indeed do with unit tests. To test the behavior, yes. So this actually tells me that you guys are really, really already on a high level in the sense of making those decisions and unit testing. So to recap, we also have seen people who were saying, yeah, well, I was forced to do this because a senior developer told me that my code should not go into GitHub unless I have a unit test. Or if I don't write unit test, the build won't pass. Or somebody said, yeah, but we need this thing called coverage, so that's why you write unit tests. No. The real thing is you want to ask yourself, is my code working? And a lot of these things were already in the word cloud. So, and you want to also check, is my code still working? Or do I want there to make a change? I saw a lot of people also put in refactoring there. And then the question is, will this change affect other parts of the code? So you have the regression part. And then the most important part is, do I trust my code? That is why I write unit tests. I want to trust my code. So do you trust the code? That is the most important thing about unit testing. You want to trust that your code meets the requirements. And how the better your unit tests are, the better the better the trust will be. Now, and then the question, why a bigger test scope? Well, I have two designs here for you, and then the question is actually, which design is better? So I'll let you ponder this question for a bit. But some of the giveaways are also that one side is red, obviously something to stay away, and the other side actually is green, which is the preferable color when we run our tests. Actually, nothing wrong with a little bit red, but in our designs we want to see green. So here you can see that this design, it is better to have something separating your users and your services in this instance. And if you now say, hey, Peter, why didn't you draw some straight lines? Well, I didn't draw this diagram. This was actually something that was done by Uncle Bob himself. And this was a blog post in 2017 where he wrote about how architecture would harm, that does TDD harm architecture? And he explained there that if that is happening, you actually should make your test scope bigger. And I also see that his head is now cut off by the techexcellence, but it looks like he's wearing a techexcellence hat. So he's a great promoter of this channel, I'm sure. But the important takeaway from his article was then that if you find that your tests are hampering your architecture, your test scope is probably not correct. And that was the first thing that set me on the path of thinking about, what does he mean? So let's look at the problem with being small. So here we see a tree which could actually be something that we wrote every day. We have mappers because all we do when we code is most of the time is moving data from one side to the other. So we have mappers, and it's very obvious for a mapper to map a single object, and then if there are sub-elements, we derive that to another mapper which could have another sub-element, and then in the end we have something like an enum that also needs to be mapped. This is not a very unlogical tree. But then when we have a lot of small unit tests, we'll end up with very tight coupling between the tests, because then every class should have its own test. So we have a response mapper test, we have a sub-element 1 test, we have a sub-element 2 test, and in the end we even have an enum mapper test. Now, of course, this is a little bit over the top, but actually I'm working in a system that was built with this paradigm in mind. And it's not fun to work there. Because the problem, if you think about it, is that if you tightly couple your small test to the coding structure, it actually means that when your code structure changes, your entire tests become unusable because they will also change and need to be refactored. And of course, we have some tooling for that, but if you do a bigger change, your tooling will not help you. And this will make refactoring a hell. And that is very bad because it means that when you need your test the most, when you're making changes, then those small tests are not helping you. No, they're even actively working against you. It will simply mean that you have a lot of compiler problems. You need to sort it out. You cannot run your tests because you have to change them. You have to change because the structure of your code changed. Another very big problem with this is that these tests test the interaction of your classes. They test if the coding that you did is still the same. They don't lock in the business concepts of your code. No, they lock in the interaction of your classes. And that is really a bad thing. You cannot go with those unit tests. You cannot go to your business analyst and say, look, I have this problem. I see this weird behavior. I made a test to prove that behavior. No, you can't because it won't be there. So let's take a look at some small scope tests. I'll switch to IntelliJ. And this is actually not the small scope test. Let's go there. So this is a small test project I made myself. So here we have a small scope test. And you can see that we have some mocks. Some information comes inside our shopping service card. We get some, we map it. And we map the total amount. And we just map this information. But what do we actually test here? We just test that when something is called, it will return a set amount and it will actually pass some information out. But what did you actually test? You just tested that this class is being called. You didn't do anything particular interesting. And especially if you look at mappers. Oh no, those actually do test stuff. But so because we have these mocks, it doesn't actually tell you anything. And especially if you go to hierarchies, if you go to the classes very high in the hierarchy, you will see very silly things. You will actually see classes that are mostly built of mocks. I'm pretty sure that if you go into your own code base and you look around, you will find those classes. You will find those classes where you will see mock, 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 verify, 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 or pass in a object and see if you get that object back. Those tests don't tell you anything. And the biggest problem is that you cannot discuss these tests with the business. You cannot map them on functional requirements. If I tell yeah, but we have this shopping service class and it will call a mapper that need to interact 2 times with, and then it will call the send to the database service because we need to save that thing. And that saving might be a requirement, but most of the stuff is no requirement. There is no functional requirement for your test. And that is why I think that mocks are really something that should be avoided. And if you look up, Martin Fowley also had some opinion on this. He said in the beginning, I didn't felt very bad about using mockers, but he is very concerned about the consequence of coupling tests to implementations. Because if you test your, if you couple those tests to implementations, your tests are not flexible enough. So this is an interesting article. You should look it up if you have a chance. But he really says you should, that while writing the test, you focus on the result of the behavior, not how it's done. I think that's a very important thing to take away. So let's do a little thought experiment. Let's look at a bolt and a screw. I have them actually here with me. So we have the bolt. Oh, this is the bolt. Actually, we have the screw, and you can just put it in the chat. I will take a look. So, well, how can you test this? How would you test these things if you were using mocks? I mean, you can come with all kinds of ideas. And if you look at the screw, it's actually a very nice screw. If you see like this, it has a very nice white head. But then if you turn it around and you look at the other side, you see there's all kinds of rust. So it's actually just a nice front end with some rusty back end. So this stuff actually works very good for as an analogy for some of the software projects that we will work on. So how can you do this? I mean, we could, of course, it all depends on whether this bolt matches the screw. We could, of course, I don't know, we could use micro radar and we can then measure all those little knots and see if they actually match the inside of the bolt. We could also, we could assert the measurements. Yeah. Well, also somebody suggested as a very good suggestion. Why is my laptop shutting down? Somebody else has also a very good suggestion that we could just build a large building on top of it. We could also use wax and make an imprint to, for example, make a reverse, then cast it, for example, make it with clay, and then we can actually see if those fit. Or you can also just put them together, attach the screw, and ta-da, we're done. We tested it, it fits, it works. So that's why I think that we should actually make our test scope bigger. It shows a little bit the thought experiment that why are we testing everything in isolation? Nobody said we should, and it doesn't make sense. Now, of course, when it comes to bolts, they sometimes actually test them in isolation and do all kinds of different tests to actually see if the nut is actually strong enough, if it's secured, if it keeps its traction, etc. There's a lot of to it when it comes to bolt testing. But you're not going to test every bolt that way. You just assume that they will work. So when I say, so now we come to the conclusion that bigger scope is better, we can look at about how we could do this. And I prefer to go for a high-level interface, perhaps a REST controller, subpart, something that has a stable interface. I think that's the most important part. You should test against a stable interface. And then I write unit tests at that level. And of course, because you have a bigger test, you perhaps need some more stuff. You need some test data generators probably. You might need some matcher helpers. And if you also want to test your flow to the database, you also need some test infra to set this up, to spin up your in-memory database, pre-fill it, and set it to a moment where you actually want it to go and when you want to play it. So you have to do some extra work to make your test scope bigger. And sometimes people will now start saying, but these are integration tests, they're not unit tests. And I tend to disagree with those people because I really feel that we should loosen up. We should not be that strong in a distinction between unit tests or integration tests. So let's look at some bigger scope tests. So let me go here. So if you look at bigger scope tests, you will see that you, for example, just auto-wire in your shopping cart service. So instead of going through having mocks here, you just say, all right, I'll take the service and I'll have some input in there. I'll catch the output and then I will assert whether the input actually makes sense. And you already see one of the problems with bigger tests is that you end up with bigger asserts, but there are ways to work around that. You can also see that we can change to the test builder. We can add some more stuff. And if you run this, it will just run, it will start, it will run in 500 milliseconds. So it just starts Spring and it's done. I have a fast laptop. Every developer these days has fast laptops. So as you can see, it's quite fast. It actually, you don't even, and once you started it, it will actually be very fast next time. So the first test is expensive. All the other ones actually come for free. Well, this is one way to make them bigger. There are also other ways to make them big. For example, here we have a client where we don't use Spring actually. This is an external service which will send out a message to an external service. We actually mock that service because, well, you shouldn't be too big. We don't actually want to be calling an XML web service. But the client which will translate this message will actually test it, will create the object, and this is another way of making them bigger. And we can simply test them by indeed using mocks, but we test the entire flow. We have no small tests for everything else. We have some bigger tests here and some smaller tests with some fewer asserts. But the big thing about these tests is that you don't test all these classes mentioned here separately. You test whether they work together and solve your problem the way they should. And I think that is a very important takeaway. We will come back to this code later on. For now, I will continue the presentation because, of course, the good thing about bigger test scopes is that you can have tests that you can explain to the business. So if you go back to the shopping cart, you can actually talk to your BA or your business analyst and say, look, when I put in 4 objects, what should be the result? If I put in this client, how much discount should I get? You can actually turn business scenarios into unit tests. And you can't do that if the tests are really small. Well, I showed you how to make them, or at least part of them. And I also showed you some of the hurdles with a bigger test scope. One thing is that you need more plumbing code to get them set up. That is a drawback. You need to say, in some reason, you say, look, get this whole thing up and running and let's go. you need to wire up your system. You also need more asserts and more setup because, well, you're going to do more stuff. So you need more setup. You need more asserts to check whether things are right. If I just need to test if I put in A, I get back B, that's simple. But if I have to put in 4 things and then make sure I get 5 things out in the right order, I need more asserts. And one of the biggest challenges is that if you want to test everything big, you might end up with an exceptionally large amount of big tests, which is not easy to maintain. So testing every single small aspect can be really hard when you test big. And last but not least, a big problem is that they fail actually when a business requirement changes. So when your requirement changes and your tests reflect that requirement, they will fail. But wait, that is actually what you want. This is the biggest advantage of a bigger scoped unit test, that if your requirement changes, a meaningful test will fail. It will not result in you having to scroll down and see that where the error is and then add a unit test there specifically for how that component should change. No, you change the entire flow. And that is a really powerful thing about bigger tests. All right. Another wise man says you should couple your behavior, your test to behavior and not to the structure. So I'm not just, it's just not me saying this. This is the guy who literally invented unit testing and test-driven development. So we should really step away from small tests and we should make them big. Well, how to make them bigger? I'm not sure about you, but in all the projects I've been working on almost my entire life, I always had Spring Beans in there. So just having a simple test running there, you can actually just use Spring and say, look, Spring, and just Spring, not Spring Boot, just Spring, boot up this component, run it, and load it up. So let me see if I get some more. 1, 2, 4, 5. Which am I missing? All right. So let's look at a very big test that we have here. Part of it is in Dutch. I have to apologize for that, but this is actually some of the tests that we wrote in production. So it will auto-wire an income function. And I heard that Daniel knows Dutch. So if you want to just translate it, just ask Daniel. And if you then scroll down to where that test class is, there's a simple configuration here that says, all right, load everything in the calculator package or in the sub packages, load it up. It's just a nice way to have a static config test. And then you can at the top, you can tell Spring to load that test config. And this is a very small class, but you can also use it to replace certain services with mocks. You can inject stubs. You can do all kinds of stuff in your test config class. So this is one way to do the plumbing. The other way I already showed you. That's over here, where we just use the constructor and we inject. And this is something that I wouldn't say is a good thing. It will quickly run out, and it's also the good thing about it, if you change your structure of your objects, at least you get compiler errors telling you, hey, we should inject some more classes here. The bad thing is that this quickly becomes unreadable. So this is not the best way to do it. But if you're in a rush and you don't want to use Spring, you have just a couple of classes, why not start this way? I mean, you ain't going to need it yet. So it's very good to a way to make sure that you can do stuff without Spring. But we usually use Spring, and I'm not sure how many of you have ever launched their controller class and then forgot to add the component. thing in there because the unit tests were all fine, but nobody complained about the components class not being there or an add service annotation. It happens to me all the time. And if I write a unit test like this, I'll make sure the class has to be found actually. All right, let's look at some more sheets because you gotta love your PowerPoint sheets. So the plumbing is just there. You can use Spring. You can be your own dependency injection framework like I showed you. I showed you the code. You can just inject, and be happy with it. You can be funny and you can use Google Glue, so you have two systems of injecting, but it doesn't really matter. I would say if you're using Spring Boot, Spring will do fine. Just as long as you make sure you don't start up expensive stuff like web servers, databases, etc. And if you want to start database, that's fine, but then you should try to keep it isolated to a few classes and not to every test in your system. All right. Then there's another aspect is that you need more complex test objects. So I like to use test builders to build objects quicker. So in this example, I have an invoice test builder that has some default values. It has builder type setter, so you can nicely chain them. And you can see it's very easy to to compose your object this way. If you have more builders and you have your entire chain done with test builders, you can in the higher level just say, all right, just send everything to that other test builder. So you can delegate quite easily and compose your objects the way you want to. But you can do even more fun with it because as you can see here, this is a test that makes a calculation of people's income. I work for a mortgage bank, so we need to know people's income, and every income type has different reasons and different ways to calculate it. And that's all being done by the business, and they like to change it all the time. So we have some tests there that will, for example, check about every type of income people have. So what you can see here that we built some scenario input, and if you look at the scenario input builder, we have just a date that starts the calculation, a number of dates, and then we have something called the mapped income per person, because in the Netherlands you can either be with one person and buy a house, or if you are married or you have a physical partner, as we call it these days, you can actually add the income together and then you can both buy a house. As you can see, the fun part about it is that if you look at the test, you don't even see that. All right, we have to add income to our request, but you don't see the distinction that there is actually another object. So that is one of the great things about building your own builders, is that you have the flexibility to do all kinds of nice things. And as you can see, there can be two, and this is aanvrager, that is the person requesting it. So this would be the client. He has an ID or some kind of ID, and then we say all this income is for this person. If you scroll a little bit down, we also sometimes have two persons having these IDs. And as you can see here, for example, this is something that we were working on. We said, okay, we add the aanvrager, and then we add income for a specific aanvrager, and you see you have this thing everywhere. And I looked at this code, I was like, look, there is duplication in there. So let's go to our builder. Is this true? And let's see, what did we do? We put a private string here, latest aanvrager ID, and we added another, and every time we call the add aanvrager, there can be only two, but there might be even three. I don't know if the law ever changes. Then there's actually a way that we say, okay, we store the last ID was added, and this allows us to have an income type, but just says, all right, if you don't tell me which aanvrager, which person this income belongs to, then I will just add it to the latest. This is the kind of optimization you do to make your builders nice. And you would never do this in production. You would never in production assume that if you add income, it will probably be for the last person you added. But in your test, you can just do that, and it makes your test just a little bit readable, more readable, because I could actually now remove this here and here, and this test will still work. Because it will implicitly assume that if you add an aanvrager, then the income should be for the next one. So this shows you a little bit how you can make your life better and your test even more readable. And you can do a lot of fun stuff. And that's what I like about making those tests bigger. It opens up a new ecosystem where you can experiment, where you can do things without actually hurting anybody, because hey, it's test code. It doesn't go to production. It doesn't have to be super efficient. It even doesn't matter if every test is slightly different. Of course, if you would have like 15 extremely different tests, ways of writing tests in your class, in your code base, that would not be good. But it's also not that bad to evolve, to learn, to make things better. All right, let's go back to the PowerPoint. So I think that's a really strong point. I like test builders, so don't confuse them with auto builders or records. The great thing about test builders is that they have a default value. So things you don't care about will be taken care of. Are fields required? They will make sure there is at least a value. And I think that is really strong in the test builders. And then, as I said, you can chain your test builders for better semantics. You can just, I mean, this is fun to do, to think about your data and then think, all right, how can I make my the building of my request more agnostic? So you can go to town. You can even write your own domain-specific language. It's really fun to do. And once you have this way of making things, you can even then tie this to, for example, Cucumber, and have some Cucumber tests where you can actually make this work. Then there is another thing, that if you make your test bigger, you end up with a lot of asserts. And this is really hard to mitigate, because if you have a complex object and you want to have all those tests, then at least there should be somewhere, there should be a moment where you say, all right, I have to test if all the fields are set correctly to what I think. So if you then look at some more code, at its test, you can see we have here a test with a single product. We build it and we say generate the shopping cart output. And then you will see we do a lot of things. We check all the products and we check the totals. And these are already a lot of asserts, and you can imagine that if we add more things or more products, it will be bigger. Perhaps to the point you think this is an unreadable mess of asserts. And you're right. So in the next test, where we have 3 products in there, I actually said, all right, I already checked in my assert that all the fields are set. So let's at least make some high level changes. And then the most important part about this is if I have multiple products, I expect that the amounts will be better. They will be more add up. So you should be smart about it. You should try to write your test in a way that you don't have that many asserts. And also you can apply clean coding standards. Just don't repeat yourself. You can test only small aspects of your set of what you want to test. So you saw an example of that. And things you can make helper functions, delegates. If your test classes get too big, you can also consider splitting up your tests in multiple test classes. So you can do stuff like making a test class based on the positive, negative, and then we had a class for weird cases. There is nothing to keep you back from reordering the test in the way you think fits your situation best. And one of the things I like most is that if you really stretch it, and you see an example in here, is that so what this class does is it calculates your income for the next 10 years. So you get a size of 10 years. Let's see if I have a good example for the next 10 years. And apparently, That's important for us. So we check this, for example. So let's go to this test. We and then we calculate 3 different things. We calculate the taxable income, the gross income. We calculate income for a specific kind of mortgage, and then we have even a calculation for what our bank thinks is the best income. So there are 3 different kinds of income being calculated here. What you see over here is that I wrote another helper that says, all right, I expect that if I have this list of all those incomes, I expect it to start on year 2022, I end in 2003, and then this should be the result for everything. So I wrote a helper assert that will actually do this. And then I can go on and check some more of those things. I think we also have one. I also, for example, went for very specific income that should apparently be counted everywhere except in this case. So I just made a test case specifically for this. I could also, for example, split my test and have another check specifically for this, so it wouldn't clog up this test class. Let me see if I have some better examples in here. No, I don't think I have them yet. So the funny part is I just made another helper class inside my class where I then put in the result. I have some builders that make me allow me to say, okay, I want to start at this, I want to start at the end year. Then I have a default expected result. And I can also add a specific result. And then I just have a matches for all that just goes to a list and checks whether the default result matches the expected result. And then of course you need to put in the extra effort to have some useful messages here. But you can see the power of coding, of applying clean code strategies and delegating and making extra stuff to make your life easier. There's even an expected result here that will allow you to as a nice input field. So what I wanted to give you is that yes, there are some drawbacks, but you can turn them into strengths and also fun, because I can tell you, I'm a coder. I like doing this stuff. I like doing weird stuff with code, except when I'm writing production code, most of the time I can't do weird stuff because other people need to understand it. There is no need for it. In our code, we want to do things the same way we did before. So you cannot experiment. And when you write tests, especially when there are no tests yet, no bigger tests, then you have a lot of ways to experiment with your code. So yes, you get bigger asserts. If your tests grow bigger, you need them. They're part of what you want to test. But you can work against that by making them smaller, asserting less while still being big. All right. So this was already explained a little bit earlier. Let's assume you have like the shopping cart and there are some very specific cases in which you have to calculate specific ways. I once had a system that had a flowchart of more than 50 nodes calculating in Germany how your money should be divided across different VAT systems. And of course, if you just paid your bill correctly, that would be fine, but then you could actually pay too little, you could pay too much, you could refund part of things you already paid before. It was a terrible complex thing. And I never thought we should test that as big as we did. What we did was that we wrote a very specific test class. So we just went all the way back to here and said, all right, this thing has a high level interface. We will test against it, but we will not test it through controllers because it was way too complex. So you should just find the right granularity for your tests. So when I say test should have a bigger test scope, I'm very serious, but it doesn't mean that everything should be tested big. It's still very fine to write smaller tests for specific aspects. And you can also write small tests for a big test. But the important part to remember is that you should actually test against stable interfaces. If you don't test against stable interfaces, you will actually find yourself again in the pain that when you want to refactor some code, your tests will break. So, an important takeaway is that you can be big and small at the same time. So you can make a test that touches a lot of stuff and just put one insert in there. And especially if you have a system that slowly grows over time and adds more functionality, this becomes very common. So, for example, here we apparently want to check that if we have a proposed scenario with energy flag turned on, and of course this should never be a flag parameter, that should be with energy or without energy function, but that's a clean code topic I will not talk about now. Then we just put in a single thread that says, all right, then the result should be that energy is false when we return the result. So this test is very easy to understand. There might be a whole complex world moving around in this part, but this just checks that if energy is false, it's also false in the result because apparently it's important to somebody. And it leads to more tests, which make your code, I think your tests more clear what they do, but it will still forces you to need some big tests where you test a lot of things because in the end, those things are important. So when I think where should you stop? How big should a unit test scope be? In scope, especially if something is a pure function, like mappers, calculators, anything, it's easy. It should be in scope. So for a side note for people who don't know what a pure function is, a pure function is a Java function or any function where based on the input you will always get the result. And they are usually the functions that don't have any external calls, because if you go to database, if you go to a service, then you never know what you will get back. So I also think you should not stop at layers in your application. I think it's perfectly fine to test your service layer or your core domain through controllers. If you have a REST API, then you can either fire a lot of REST calls to that API, but why would you? With Spring, you can just inject exactly that information into your Java objects. And especially if you already have your builders, then it's not so hard to just fire up a bunch of objects, throw them into your request, and actually test those true values. External jar files, why would you put them out of control? I had some discussions in my team that they say, yeah, but then if you change the jar file, which returns some calculations, then those numbers change, and then you have to change your test. I said, yes, exactly, because you did something. You upgraded a version in the POM, and now your tests behave differently, but they should be the things that you expect there to change. So there's nothing wrong. Then there is a business reason why it changes. And also databases. I mean, you have to be careful with them because it takes more time to spin them up, but it's very easy to unit test some databases in memory with everything we have these days. Only problem might be that your in-memory database behaves differently than your non-in-memory database. So that might be, it's still always tricky to test your database, but it is especially, I wouldn't exclude it. And what's out of scope are external network calls. So the moment you are calling external services or you want to call database on the other side, that's no longer a unit test. Then I would definitely use a mock, or actually it's a stub, but I would use a mocking framework to stub your returns. And you can do a lot of things with that. One of the examples, what things I really like to do, last tricks I will share with you is if you look here, we just saved an XML file with the response that we usually get. and then we just put that through JAX-Bay. That's what you use to unmarshal it and return the object tree. So it's a really nice trick, and I heard this more often. Also with JSON request, if you want to test with external content, you can just spy on the connection, capture some of the content, save it to a file, read that file from disk in your unit test, and then start testing. It's a really powerful mechanism, and it has the benefit that you also test immediately your mappers if they still work, because that's auto-generated code, but it's still nice if you know it still works. And as I said, everything I said is a guideline. You are in control of your own fate, but I think it's really important that you should make your test code bigger. We should stop those excessive mockings, because I see time and time, and when people say, Peter, we don't like TDD, and we hate those unit tests because they don't help me at all. 99% of the time, it's because of excessive mocking, because those tests are so interwoven with the code, they're so tightly coupled that, yes, of course, they will hold you down. This presentation was basically based on experience I had that we were doing a big refactoring, really important one, and we couldn't compile our code for a month because the unit test wouldn't even compile. We had to disable whole unit tests just to make our code compile. And then when I realized that this is so inefficient, this is just beyond anything you wanted to do. So what I really wonder is, how do we get to this point that we start all this mocking and we said, oh, we should tie every class to a unit test. So I really want you to base your unit test on business data. I think that is really important. You can sit down with users, with your business analyst, and say, I have this problem. Look, I have this test that proves that we have a problem. How can I solve it? And what I don't want you to do, of course, is stop writing tests or stop feeling free to write small tests and only think big. It's a guideline. This is something that I think we should be more aware of as professionals, as a software craftsmanship community all over the world. We should think about it, but of course, you're still free to do whatever you want. With that, I come to the conclusion of my presentation. I thank you all for attending, and well, if I understand correctly, there will be some questions, and I'm really looking forward to a discussion.
Exactly. Thank you very much for your talk. It was a great and informative one. I really enjoyed it. Personally, I like the part when you emphasized on writing clean tests, right? Because in my opinion, clean code requires clean test, and with those test builders and fluent asserters, you really make your test clean, so it's easily maintainable by us. So great session, great job. We
Daniel, I also want to add also one more thing which I found quite useful regarding test scope size, because that is probably quite always a controversial topic. I like how essentially Peter showed that diagram from Uncle Bob, which essentially explains that in terms of coupling, I found that one was for me, well, a mind changer when I first discovered the approach. So I suggest that everyone look at also Uncle Bob's article, because it can be simply, I mean, explained in terms of a level of coupling. And the other part that was also useful is at the end, the exception when to not use wider scope tests is when we have combinatorial explosion. So that was the case of VAT calculation rules, for example, for German bank or something like that. That's the exclusion. So I found that this was a good balance.
Exactly.
Yes, you should
Perfect.
always feel free to just go back and say, all right, but this is so complex from the higher level. I just go down and I find a stable interface, and then there I will just make very specific tests. But still, then probably also in those cases you have actually the business analyst say, yeah, but this is a complex function. So I have this document of 14 pages for you. That's a good telltale that you actually should consider moving it in a separate component.
Excellent points. Thank you. I will propose to go through the questions. We had some exciting discussions in the chat. We also have some questions. You can answer those, and also some discussions we can touch, and we can see how far we end up being at with these. Let me show the first question is from Maximiliano Conteri. He's a big supporter of us. He's always here. Thank you very much, Maxi, to be here. So his question is the following. What do you think about London versus Chicago mocking schools?
So I think the London school says that you should mock, right? That's not a classic approach, but a London approach. So apparently then we have another subset of the mocking schools that says that I'm not familiar with the Chicago mocking school. So perhaps you, Valentina or Daniel, do
Yes,
you know?
yes. So here the precise definition is in the Chicago school. Mocking is done only at the architectural boundary. So as soon as we're crossing to I/O concerns, so like database, file system, external network calls, like calling some other REST API, SOAP, or anything non-deterministic, such as the system time or something like that. So it's very minimalist mocking. So mocking only at the architectural boundary when it says, I said, IO concerns or non-deterministic, and nothing else. That's it.
So that sounds a bit like
Whereas, yeah,
that sounds a bit like the approach I am proposing, right? That you say,
it
look,
is
no mocking at all.
your approach is, I would classify it Chicago school, and even maybe a notch even more than
I think
Chicago.
the dangerous part is when you say at the architectural boundary. Because what is an architectural boundary? If that means if you go for your controller to your core objects, if that's your architectural boundary, I think we should not mock there. So again, it's
Yes,
I don't
so
like all these different tastes of in schools and ways of doing things. I think we should just keep mocking to the absolute minimum.
that's why I say your approach. There exists approaches which use even less mocking than, I mean, Chicago uses a small amount of mocking. Then there's people who use even less mocking than Chicago. That's where you belong in, which is useful. I mean, so that people have reference when they're watching this presentation.
So
Whereas
then should we name it the Dutch school or
I think
perhaps
so. I think
I,
so.
I'm more like I guess this I will call it the Peter Schuler school. I don't know.
I think
I
you
would
should.
I
Exactly. And the other thing is again about mocking. So whereas in mockist school there's a lot more mocking, so we would essentially mock out any mutable dependency. So as long as we're depending on some other like interface which has some behavior, we would mock it out. So the other example that you had where you had multiple mocking, okay, that would be more similar as the Mocha style, and that's where there's the difference in terms of design approach. So in the Mocha school, the mocks are used as actually to help you guide design. In Chicago school, we don't use the mocks to guide our design. So yeah, that's the short overview.
I
yeah.
completely
So
agree.
so to come back to the question, if I have to choose, I will go to Chicago and not to London. But
Okay.
I rather just keep mocking to an absolute minimum.
I completely agree with you here. I mean, like which one to use? We should really forget about this London and Chicago. We should focus on, testing the behaviors, and maybe we need to use both in some, scenarios, right? I mean, software engineering is not black and white, and we should always, apply something if it makes sense in the given context. And if it makes sense to create a mock, yes, let's do it. But as you said, we should keep those mocks minimum because otherwise our test will be too fragile and too coupled to the production code. Great. Let's see here. There is one additional point from Maxi about unit tests. He says unit test definition says nothing about testing, just one function. It's a common misconception. I think it here is
Yes,
him. Yeah, maybe here you have
there's
something
just
to.
to say yes, and that's something I think we should actively um, bring to the world to fight this misconception. I wondered, I had a discussion with somebody who said, why did we end up this way? Why did we end up with those 1,000 mocks classes? Somebody once said, oh, that's a good idea, let's do that.
Mhm.
And perhaps it made sense in the early days when we had like a big controller and a big service, and then either a database and something, and then but somehow we took the wrong turn. Everyone's like, yeah, let's go mocking, and that's something we have to correct now. We have to say no. Unit testing was never about a function or a class. It was about a unit of behavior. So yeah, Maximiliano, I think you asked the right questions, or you state
Ex-
a fact that is indeed true. It's a misconception, and I invite you all to go out in the world and tell, no, no, don't do this.
Exactly. A next question could arise from this that how do you test your classes? And the answer is you don't, right? You test your behaviors. So
Exactly.
absolutely. Valentina, do you have something to add, or I can jump to the next?
No, feel free.
Okay.
I will
Yeah,
jump
okay.
in if I have something.
Yeah, okay, okay. Yeah, yeah, okay, all right. Perfect. So here we have a question from Sasha Dumer. So bigger tests are the same as the common integration tests? Please, Peter.
Yes, we also have the honeycomb testing these days. It's a microservice structure. Could have put a slide in there. But yes, I think the distinction between integration test and unit test does not help us at all. Um, so your test should just be as big as possible. And if you want to call it integration test, fine, fine by me. What I like to do is just see things as unit test and an integration test. In our language, in our team, we just say, okay, the integration tests are tests where we start up Spring Boot, we take a JSON, and we shove the JSON into the system, and we check the response, and we match if the response is the same as the thing we expect. And that's a very good test. It's a very they said gross grain test. So if something breaks, you really have to think hard. Why does this break? What is going on? What is uh, did we get the wrong variable somewhere? Did we are on the wrong date? It's really those tests are not really useful except that they
Mhm.
build in trust, because if they pass, we know that some big scenarios still return the same result. So in my sense, I think bigger tests can look like things people used to call integration tests, but I would say let's just move down to it. And if you Google for this honeycomb testing, you will actually see that there are less small unit tests and more bigger integration tests, but I would still drive them through the unit tests. But it's
Mhm.
a common thing that people say, "Hey, what about this? What about these integration? Aren't these integration tests?" I feel that the distinction should just be dropped. And I really like your
Mhm.
dogs, by the way, Sasha. They match good with my dogs.
Uh, Great. Here we have an additional point from Maxi about this, about integration tests. Namely, he says integration tests are slow, unit tests can be big and fast as long as you don't have coupling. So what he means is maybe one rule of thumb, the difference between unit and integration tests, that integration tests are slow, unit tests are fast, they run
Yes,
in some milliseconds.
they should be fast. And I would drop the milliseconds, because then if you want to use Spring, you're already on 500 milliseconds, but you
Okay.
don't notice that. And once the first one starts, they were really fast. So you end up with with lesser, smaller tests, and then a few bigger tests. So and of course, if you have just mock-ish tests, they're really fast, because wire mock is like take milliseconds to start, and Spring takes half a second. But
Mhm.
then you have less of those tests, so yeah,
Yep.
you don't really
Yeah, I
feel.
just want to add, yeah, this was definitely a good, I mean, discussion, and there was some back and forth. So maybe I think it would be a good idea now, maybe Daniel, if we could then show the other follow-up
Yes.
comments regarding these discussions, just so that it's displayed maybe for a few seconds so that everyone can see.
Here we have this from Maxi. Dependencies do not necessarily make your code slower. Accidental dependencies like a DB does. And one more from Sasha Dumer. Integration tests are not slow. It depends on the functional domain. The bigger you scope the functional domain to test, the slower they get and the more dependencies you need.
Yes, but I think, yeah, I think that's a very important point that you made, Valentina, and also everybody in this, at least in the discussion. It's also about definition. Why do we call something an integration test? Because it tests more than two classes? No, I like to call things integration indeed that are like bigger tests, perhaps even call subsystems to see if we interact correctly, or use wire mocks to see if we correctly work with the stubbed inputs. It's write to databases a lot. Uh, but then again, as I said, database doesn't have to be outside the scope, because for most applications, it's far too important to say, oh, the database is detailed. That's not something that will really actively work. But
This
I
is a
think
good thing that you mentioned. There are, I mean, approaches like Vladimir Korikov, whereby he essentially is saying that he goes beyond even Chicago school to say databases should not be mocked. So I think maybe you'll find some similarities there as well. But yeah, this whole discussion, which does keep on coming up in probably nearly every meetup about unit test versus integration test. So from Martin Fowler, he wrote an article about sociable versus solitary unit tests. So in the sociable unit tests, which is the classicist TDD style, everything, I mean, we can have multiple classes being all together and it would still be called a unit test, not an integration test. But in the Mocha school, if those two classes are essentially collaborators, then testing, yes, those two classes would essentially, they would call it integration test. So that's where all of those naming, I guess, challenges come from.
and I think the weird part is that we do that to ourselves. Computers don't tell us to call things unit test or integration test. They don't tell us to call them sociable or social or solitary. We come up with all these definitions to define I don't know what. I'm a very practical guy. I once followed the Mocha school because everybody did. I learned that was not the right way to do things. And it was a slow road for me, but I got there. I think we should just be practical. Don't get stuck on names and paradigms and think, all right, this is the way. I'm not sure if you guys ever seen the Mandalorian, but he says this is the way, and he never takes off his helmet. He even prepared to die before he takes off his helmet. Um, that is not the way. The way is to be practical. And I really find out that bigger tests, and if you want to call them integration tests, that's fine. I think you will end up with problems having them to find new definitions for actual integration tests, but just be practical with these things. And don't be like a crusader and fight battles. Yeah, fight for test-driven development. That is something that will actually work. And fight for bigger tests with how to name them. Be practical.
It comes down to coupling in the end. So I get what I found for myself more helpful is, instead of thinking about the whole thing of terminology, unit test versus integration testing, to think about essentially coupling your test to stable boundaries.
Yeah, as always, Valentina, you put it much more elegant and with much more thought in it than I do. But yes, you're right.
One more comment maybe is the last comment of the chat regarding this. For me, it is integration tests use infrastructure, therefore they are slower. Unit tests don't. Whatever the scope, they usually very fast. So yeah, that can be also.
I think that's a very that I think that would be my definition as well. So when I call integration tests, I actually fire up Spring Boot and I go to the port. I might fire WireMock to see if I call my external services and get their input correctly, at least for as far as I configured my WireMock correctly. I test the whole system inside the infrastructure, and I still mock the infrastructure because we don't want to be calling in our build other systems in OTA environments and be dependent on that. You still want to have low coupling there, but you pretend not to have coupling. So you are not coupled, but you pretend to have it.
Mhm.
And those are the integration tests.
Yep, great point. Maybe one more comment about this topic, and after that we can jump to the next topic we can discuss. So here Maximilian mentioned, yep, business tests should not be coupled to the databases, APIs, or external resources.
Yeah, I'm not sure. I also see that there's a merit to say that the database is your data store is so important that to keep it out of your business test is making your life harder than it should be. But that comes down to the discussion: is the database a detail, or is it integral part of your business logic? And
Mhm.
I'm not yet convinced that it is not part of your business logic. But then again, if you look at the architecture picture, yeah, but it's a detail. So you should have another layer between your database and your. Is it really worth having that? I'm not convinced yet.
Well,
And
this is
this,
a good topic. I was actually thinking about this for the last several months. So, I mean, okay, in Uncle Bob's Clean Architecture, he essentially treats it like a detail. And I mean, in Chicago School, classically, I mean, they also, as I said, keep the database out. Then the problem that occurs is, what if, due to whatever reasons, you need to put business logic in the database? For example, maybe you have some reporting or something, and instead of loading up all data onto the client, you want to do the addition or subtraction or fractions for whatever reason on the database. And then in that case, if we're splitting the behavior test, like we're splitting this part of the calculation is on the database, this part is on the application, we actually don't have any test which tests that whole business logic, because that business logic is clearly spanning into the database. So that was one moment which made me switch over towards treating actually in those cases the database as part of the behavior. And I found it useful how Vladimir distinguishes in the unit testing book the two types of dependencies, and I think that this actually ties in with Peter's presentation, because Peter, as you mentioned, you distinguish between, I mean, you treat database as part of the current system, so you don't necessarily put boundaries, but you treat it differently compared to, for example, external network calls or something which is a bit
Yeah, and
more
you should be
external.
open to have business tests actually touch your database, and perhaps not all of them, but
Yes,
because I also find out that if you just write tests against in-memory databases, like H2, you will end up at the point where your actually database, for example, I don't know, MariaDB, actually is not behaving the same, and so then you end up with test containers, and then you hope that your test container actually has the right version. And test containers, yeah, they take like 20 seconds to start. So there goes your fast unit test. So there is, I think I will take the consultant way in this, and I will say it depends. It depends on whether you want to use very specific database stuff, or if you foresee that you will, or that you have a very common database like MariaDB, or one of the where you know that your test containers will actually be up to date from time to time. But yeah, you could even make your own Docker images for your database. All those things are possible, but it's all, yeah. I wouldn't say no to them, but I also know that if you do, you have some challenges.
yeah, and one more thing I want to add there is, I would say it also depends on, again, that depends on the application that you're building. I mean, if for the majority of your application your business logic is in memory, and it was appropriate for you that the database is just an IO detail and does not contain any business logic, then yeah, you can fully separate the database. But let's say if you have an application where you have, due to performance or other reasons, as more significant part of business logic in the database, that your database might be having 50% of logic or even more, then in that case it changes the picture. So yeah, in the end it depends.
Yeah,
I
it
think it's a
depends.
whole
Also, I
topic.
think we should not forget that if you save something to the database, there's always been a cycle that you save stuff in the database and then you get it out. And you have to test if that's correct, because if that's not correct, then you have a problem. But like you describe, you should actually think about yourself: do I need a database, or can I just keep everything in memory? And if the answer is I can keep everything in a memory, then the database becomes a detail. But if you actually feed your user views from your database, yeah, then you need to have that tested as well. Because in the end, we can have the perfect logic, but if then we send the wrong data to the user, we're still don't cannot trust our system. So yeah, again.
Exactly. Maybe one more thing to add here from my personal experience. My previous team, I worked for 2 years. I was a part of an integration team, and we needed to write services or software code for migrating data from one system to another. And usually we had to write some services which migrates data from one database to another. And that's what it does. It just reads some data, maybe a small mapping conversion. After that, it writes data. And for that, we really needed to use real databases when we wanted to test it out, because otherwise, what do we test? Just a mapping that would be too coupled to the code, as you said. So we wanted to focus on the behavior on the unit, namely the migration part. So yeah, it really depends. That's the consultant way, and it does. This topic leads us to another good question raised by Valentina. I think we could talk about this. So Valentina said, DBs can be unit tested easily. This was a comment in the chat. And this would also be a good discussion topic for QA due to different perspectives. So what do you think, Peter? Can the DBs units tested easily? What do you think? What is your experience with this? What would you recommend to the audience?
I think if you want to have them tested, this can be done very easily with things like DB unit or flight weights, running a script to repopulate your database. The thing is, databases deal with state, and you can say no, there should be no state, but yeah, having no state in an application is fooling yourself, because in the end there will be state in the database. So it means that you need to do stuff like, for example, I once had a very specific flow where if I inserted something, then I needed to make sure that it was an event-driven system, and if these events were handled in the right way, then the database should be in a certain state. So I had to use actually the order test annotation, because my test had to be like write something, update it again, then delete it. It had to be in that order. It just had to be, because there is no other way to make it. I could have just tested delete. That wouldn't make sense. I had to test them in order. So that's what I mean with it's not hard to fire up a fake database, populate it, and run tests against it. And that's what I mean with this content and with this comment. And I know that there might be a harder. That's where the depends come. But I would not say don't test them. Consider them in detail. You can if you want to go pure clean architecture, but it will cost you. It will cost you more mappings, another layer you have to cross, which all have to be tested. So it will probably end up with creating a stub somewhere that will pretend to be your database when you test your core objects. And then you need to write tests that actually test if you call if the calls that your core makes to your data layer, if that will be saved correctly in your database. And I always like to cut out the middleman and say, well, let's first try it if you can get away with doing that. And that is easier if you, for example, use a GPA to generate your schemas. That makes it very easy, because then you don't have to worry about specific SQL languages. You just let it's then a detail that's being handled by your OM mappers. But if it's but as like Valentina said, the moment you start, oh wait, but there's this nice index I can use for faster searches, and I have this
Yes,
specific keyword that makes my search go faster. And believe me, if you deal with a lot of data, in the end you will end up with things like that. Then it becomes
exactly.
harder, because you then need a very specific database version. You might end up cooking your own Docker images, which will take time to spin up. And then you might want to have stateful unit tests. So you say, all right, I have some kind of unit integration test that will run, I don't know, 500 scenarios against a test database, then throw the test database out and reset it to the state it was before. Options. But I would not say leave it out by default. I think dealing in absolutes is really wrong to do. And when I was younger, I was like always there for absolutes. But as I'm aging and getting like wine, getting better, I see that we should not deal with absolutes.
Yeah, I really like how you explain this, and essentially the different possibilities that people have when it comes to the database. One approach was, as you mentioned before, I mean, test doubles. For example, if someone has a fake database, then someone does need to do separate integration tests for the database and separate for the business logic. Other people might use in-memory databases like H2 or something else, but then again, that might also cause some fidelity or realism issues. Then there's also the approach of using the actual real database, but with Docker images like test containers. I think those are the three approaches that at least I'm aware of. Not sure if there's a fourth. If anyone knows of a fourth, feel free to say. But yeah, it's a good discussion topic.
Okay, excellent. Let's jump to the next question from Ilyas El Madi. How do you test behaviors with combinatorial explosion?
Yeah, hard work. It's just, yeah, you have to test all those combinations. But I mean, how many can there be? I know that people say, yeah, but if we have 14 fields and they can each be null, then we have at least 14 tests where just one field is null. And then we can have one where two fields are null, and then we have like, yeah, and then you go indeed in an explosion of possibilities. But why not have a test that tests if 40 fields are null, if things work? If that's true, then probably it will also work if just one of those fields is null. So be smart. And then if there really are combination explosions, then, well, write some helpers that will actually generate test data for all those combinations. I actually work now on a project where we deal with mortgages, and they can be very complex with all kinds of payment options and tax advantage you can get, and the rules. And we actually built an entire framework in a different language, a MATLAB language, um, which will generate cucumber files for us. And we run it, and it will almost fry my laptop, so inefficient is the code. But then after 5 hours, we have like 3,000 cucumber files with more than total up to almost 350,000 lines of cucumber, which we can then run against our database. So we have this combinational explosion, but we dealt with it with creating a second framework that works, that runs as a shadow implementation of our functions. So we always know that our calculations are correct and they will be correct. And we run this test suite every time we go to production. So
That's really interesting. So essentially here you do have tests which are actually doing calculations with all of those different combinations, and where
yeah.
there's quite a lot of tests, for example, to be able to.
Well, we find that in the end, it are the business analysts and we as the team that make the test scenarios that generate all these numbers. And we still find that we are humans, so we forgot some things. It's still very funny that if we change something fundamentally, we find out that no tests actually fail. So there are gaps in what we told them to do, but it does allows us. For example, we calculate our mortgages for 360 months. That's 30 years. So we have 360 months of all kind of numbers that have to match up to the cent. And
Mhm.
you cannot write that in unit tests. That's impossible. So that's why we wrote this
Yep.
shadow implementation that will actually generate cucumber files. And then we wrote the fixtures in our Java code, and that's where we run those tests. But it is harder again for you, because if I have a mistake, more than not, it happens that the mistake is not in my code, but actually happens to be in the shadow implementation. But it's the price you have to pay, but it also makes sure that we can make big changes, make sure that all our tests pass and go to production. Instead of have to go, but guys, can you do some manual testing? Can you test those through the 60 months for 14 cases? So it makes our code really stable and flexible, and we have very little regression. I only have one regression test in mind where we saw a bug and we fixed it on the wrong side of the. We fixed it actually in the shadow implementation. So yeah, that was a requirement mistake that we make. So yes, you first of all you should not worry too much about combinatorial explosions, in the sense that you should not create them yourself in your own mind. You should guard against that. Secondly, if you actually have that, well, you either end up with a lot of tests that you have to write manually, just go through all the options, or write something that will help you. In the case of the German tax office, I actually had, I think, 300 tests at the end, but they gave me coverage of 100%, including branch coverage. So I knew that I had covered all the cases. There were even some tests that I knew, for example, we didn't do the rounding right, because if you pay 10 cents in 3 times, you're stuck with a cent. Where do you let that cent go? But yeah, we just told the business, look, this test fails, it's disabled, and we put a note that it's that we just don't know what to do with the cent. So good luck with the German tax authorities if they come looking for that cent. We told you.
Yeah, excellent point. It's all about gaining confidence, right? So we write tests for gaining the confidence as the main point. Maybe one more thing to add here regarding this. Lately, I am involved in a project where we are having a lot of mathematical computation, algorithmic computations, and we need to test those. And we have the same challenge of how to do this combinatorial explosion, or how to test the given function with different kind of values. And what we use there is a property-based testing. So with the frameworks or libraries of property testing.
Is it me or did we just lost Daniel?
I think maybe it's just Daniel, but while he comes back, I do have some comments, additional ones to say on this topic, because I think it's a really good topic. So I see here basically two possibilities. At the level of the developer, okay, so the developer writing the actual unit tests, the two possibilities are either writing tests for all the possible combinations and having a lot of tests, but you do have the higher confidence, versus going at a bit of a lower level, whereby you break essentially the combinatorial explosion by testing at a bit more granular level. And that's something which I also needed to do in the case where there was some mathematically complex parts where there was combinatorial explosion, where I actually did go down to the lower level. So I see that as one dimension, like what do we do at the developer testing level? But then at the other level, business analysts, the fact that it's fine for them to spend, for example, a whole day, I mean, maybe that's their main job, and trying to think of all the various combinations. In that case, that actually then does enable you to get even high confidence tests, because you have someone else who is preparing all of those hundreds of possible data combinations.
Sorry for this. I don't know what happened.
No
My
worries.
internet disconnected. I don't know what you hear from my sentences, but I think maybe Valentina completed it properly. So what I wanted to mean is, with the property testing frameworks, we can generate, the inputs in a given range, and after that we can, by using these inputs ranges, we can probe our given functions. And we use it really successfully. And the good thing is, with property tests, we can learn a lot from the behaviors on the function, and we find a lot of bugs as well. So I just wanted to add this. We still have 2 minutes. Maybe here there is one more point from Maxi. The next I wanted to highlight. It is a fails dichotomy to test the DB or mock it. We should not even be aware we need a DB, in my honest opinion. Maxi is telling this.
Let's agree to disagree, because I think in the ideal world, yes, but in the real world, state has to live somewhere, and most of the times lives in a database, and you can. It's like Valentina said. If you do that, you still need specific testing your database, your interaction with your database.
And just here to be clearer, so what it basically means is, okay, let's say someone is following clean architecture fully, and you do have those repository interfaces. You are, number one, making a conscious decision which parts of behavior are in your application, which parts are in the database. So for me, that's actually consciousness and awareness. You're actually putting a split somewhere. And then in terms of testing, you then consciously are testing something in memory, and you have to then, if you're making, for example, if you're using fakes, you have to test against both the fake implementation and real, so the fake and the real adapter of the database, if it's fakes. If you're using mocks and not fakes, then okay, you're testing the fact that interactions occur, but then again, you still have to test with integration testing the part where you're integrating with the real database. I see. It's a big topic. I mean,
But we can also, I mean, for me, we can agree to disagree. I think there is merit in both approaches. As long as you make unit tests bigger, I'm a happy man. So, Maxiano, yeah, I think there is some merit in what you say, and I think it depends.
Mhm.
If you want to pay the price, then it's fine. It's a fine approach.
Mhm. Okay, I think we went through all the questions we wanted to discuss. It's also 7 o'clock, so I think it's high time to wrap it up. So I would like to say big thanks to you, Peter. It was a great presentation and very informative topic. I think we all learned a lot. We covered a lot of different things. So thanks a lot, appreciate, and thanks a lot for Valentina also for hosting this event. And of course, the most important part of this, the audience. So thank you everyone to take part of this great session today.
Very much. Yeah, thank you all for having me here, and I learned a lot again this day. So I really enjoyed these discussions and these events. So thank you indeed, Valentina, for hosting me.
Yes, thank you both. Yeah, I think that these discussions today were definitely went deeper into all topics. So it was definitely fun, and yeah, thanks everyone again from the audience for really great questions.
Yep. Thank you, everyone. All the best. Goodbye.
Thank you. Bye.